Hi everyone, to the second part. I am Ahmed Magdi again. In this part, we will talk about the risk quantification. So in the first part, we know what is the epidemiology, what is the meaning of the risk assessment, what are the components, and how the risk assessment is a crucial part of the if any epidemiological process because we are targeting the risk to know the risk, to prevent the risk, and to treat the risk. And then we go through the types of epidemiological studies, and we divide it to two large categories. The one with intervention, which uh, we will not discuss in this semester, and the one without intervention. And without intervention, it may be comparing two groups, it's analytical, or just one group, it's observational. And inside the two groups, it can be in the prospective, it's a cohort; in the retrospective, it's case control; in the same time, it's a cross-sectional study. Uh, this is the most important or mathematical part of the three parts, which is how statistically we can calculate the risk or quantify the risk, and what are the methods and the challenges of risk quantification. Okay, why this part is important? Because all the items of the STROBE checklist will use some terminology from this part. So we can consider this part is a statistical terminology uh, because we will find frequently these terminologies in the observational studies. So if you know the terminology well, when you will study, read the study, you will gain the idea of the problem. Those are the components of risk assessment as we discussed, and this is why we quantify the risk. So, what are the statistical quantifiers? You will hear these terminologies in calculating the risk. You will see in some studies the expression of odds ratio, in other studies the relative risk, the absolute risk, the attributable risk, and its second name, the absolute risk difference. So attributable risk equals absolute risk difference, and the confidence interval. So let's know these terminologies and be familiar with them. So from their name, the odds ratio and the relative risk, those are standard quantitative measures to determine if epidemiological data are meaningful or not. So we have the odds ratio, which mean the ratio of risk of disease in a case control study for an exposed group to an unexposed group. So what's the meaning of odds ratio equal to? It means that the exposed group to the risk factor has twice the risk as the non-exposed group. This is again in the case control study. In the cohort study, it will be the relative risk. What is the relative risk? From its name, relative mean a ratio. So it's a ratio expressing the occurrence of disease in an exposed population to that of an unexposed population. So a relative risk of 175 indicates a 75 increase in risk with the exposure. I know it's still unclear till now. What are the differences? To know it, Again, the odds ratio is for the case control study. The case control study means that I am starting with the outcome and searching in the past. So it is an odds. I can't uh, make it named risk, because risk means that I will follow up in the future and will have the relative risk of developing the problem. But here the problem is already developed. This is the theoretical difference, but the mathematical difference will be clear if we take an example. So let's consider an example to differentiate between odds ratio and the relative risk. Suppose that we are conducting a study to explore association between smoking and lung cancer. So we have exposed group of 300 smokers and unexposed group of 400 non-smokers. And among smokers, we have 50 individuals developed lung cancer. So 50 from 300. Among non-smokers, we have 10 individuals from 400 developed lung cancer. So let's calculate the odds ratio. The odds ratio, as I told you, it is for the case control study. So it starts with the disease, with the outcome. So you will see here odds ratio. Odds ratio means that I will calculate two odds and take the ratio between them. So what are the two odds I will calculate? The odds of lung cancer in smokers uh, to the odds of lung cancer in non-smokers. So here, as I told you, I'll start with the outcome and followed by the exposure. So I'm comparing the cases among smokers and the non-cases among smokers. So here I'm comparing the cases versus non-cases, and this is why it is called odds. Odds of lung cancer in non-smokers, so cases among lung cancer are divided by non-cases among lung cancer. Among non-smokers. So the odds ratio is the odds of lung cancer in smokers divided by odds of lung cancer in non-smokers. If it is 7.8, it means that the interpretation of this, it means that the odds of developing lung cancer are about 7.8 times higher in smokers compared to non-smokers. It will come clear if I tell you, if I'm comparing it in the term of relative risk. The relative risk here, as I told you, the odds. I start with the odds of lung cancer in smoker, and here the odds of lung cancer in non-smoker. The relative risk, again, relative. By the way, relative risk is also named risk ratio. So relative risk or risk ratio, again, it's a ratio between two risks. Risks of what? Risk of lung cancer in smokers and risk of lung cancer in non-smokers. And here I will start with the exposure. So I'll take the cases among smokers divided by the total in group, and the cases among non-smokers divided by total in group of non-smokers or total in group of smokers. If I calculate the risk and tell me it is a relative risk of 6.6, indicates that the risk of developing lung cancer is about 6.6 times higher in a smoker compared to non-smoker. If you see at the interpretation, it seems the same. So the difference is mathematical. But the interpretation or the meaning are nearly the same. The odds is for the case control study. Why? Because the case control study, I will start with the outcome. So in the outcome, I can have a odds for the outcome. But if I'm starting with the exposure, I will wait some time to have the outcome. So it's a risk for developing the outcome. So I will calculate the risk and the relative risk. Those are the differences between odds ratio and relative risk. Another two terms, another two important terms, which are the absolute risk versus the attributable risk, or the absolute risk difference. So again, risk is like the relative risk because it's a risk, okay? It's not odds. The absolute risk refers to the actual or overall likelihood of a specific event occurring within a defined people over a certain period of time. So it is not a relative risk. I will not divide it by another risk. It is not a risk ratio. It is one risk, the absolute risk. So it usually expressed as the proportion of individuals in a population who experience an event. For example, the absolute risk for developing disease within a population over a specific period. So let's consider a study population where 200 out of 1000 developed a specific disease over 5 years. So the absolute risk for developing this disease is absolutely or approximately 20%. So it's one arm of the relative risk. So what is the attributable risk? Attributable risk or the absolute risk difference. What is the difference? Attributable risk quantify the proportion of the disease incidence within an exposed group that can be attributed to the exposure. It is calculated by subtracting the incidence of the disease in the unexposed group from the incidence in the exposed group. The example will make you know that the attributable risk is more beneficial than the absolute risk because it gives me an impression about the contribution of certain exposure to the outcome. So in the above scenario, the disease incidence in exposed group was 15%, and in the unexposed group it was 5%. So the attributable risk would the incidence in exposed minus the incidence in unexposed equals 15. This means that 10% of the disease incidence in the exposed group can be attributed to smoking because here 15% and here 5%. So if I subtract the chance from the exposure, so the exposure is responsible about 10% of the outcome, and this is why the attributable risk is more beneficial than the absolute risk. Why? Because I'm doing the study to know the role of certain exposure, so it's more important than the absolute risk. So if I put the relative risk, absolute risk, and attributable risk, I will see the relative risk is okay and the attributable risk is also okay, but the absolute risk is not that beneficial. So the absolute risk measure the overall risk of disease within a population, while the attributable risk quantify the proportion of disease risk that is specifically due to an exposure. Both measures are crucial in understanding the impact of exposure or factor on disease occurrence within the population, while absolute risk provide a general understanding, but attributable risk help in the evaluating contribution of specific exposure to the disease. Okay, the last one, which is okay, absolute risk versus sorry, no, attributable risk versus relative risk. Which of them is more important? Each of them have their importance because in sometimes the relative risk can be misleading. I need both of them. So if I have a study that calculate the relative risk, it is okay. But if I have a study that calculate a relative risk and attributable risk, or its second name, the absolute risk difference, it will be more powerful study. And this example will let you know why it is important. In this study, we have a group of patients, the exposed group, 60 patients, and the risk equals, so three of them develop the outcome, so the risk is 5%. And then the unexposed group, just to develop from 60, it is the risk of 3%. So the relative risk is the division of them. So absolute risk difference, 165, and the absolute risk difference or attributable risk is 2%. Okay, so this is a relative risk and this is a attributable risk. In another study, we have a risk of 66% and in the unexposed group of 40%. The relative risk, if I divide this by this, it will be the same relative risk like the first study, but the absolute risk difference, it will be 24%. So if I see the exposure here in study number 1 and in study number 2, if I see the exposure here, I will, and I'm just judging the relative risk. So the relative risk here is equal to the relative risk here. Yes, yes. But the attributable risk here is only 2%, but here is 24%. Quite different despite the same relative risk. And this is why the studies which comment on the attributable risk, or its second name, the absolute risk reference, the risk difference, is more accurate and give me another insight rather than only the relative risk. So those are the quantifiers of the risk. We take the odds ratio. So the odds is related to the outcome, a case control study, and then risk. In the risk, we have relative risk, which is the commonest one, which you will see in the studies. Then absolute risk, which has much lower benefit, and attributable risk, which is complementary to the relative risk and give me another insight. This confidence interval is not an accurately quantifier. It is not a quantifier. It is a method of expression about the quantifier. If I see the relative risk of 165, as I told you in the previous part, I have a question in statistics. What is the question? Okay, the relative risk is 165. In this cohort of patients, in this study, can you tell me if you repeat this study on another cohorts of population, will the relative risk will be the same? Here, the statisticians have some answers for this, is to know or to try to make an interval of confidence that if I repeat this study multiple times after, I can be confident enough to tell you that there is a range of relative risk will be in these studies. Let's make it more clear. A confidence interval is a range of values that is used to estimate the true value of a population parameter with a certain degree of confidence. So it quantifies the uncertainty around an estimated statistic. But it is not related to the risk. Any result I can find in a study, I need to generalize. So I will use a theoretical question. If I repeat this experiment in another cohort of patients, will the numbers be the same or no? So sure, there is an accepted range of difference. What is the amount of this accepted range of difference? And how confident you are if you repeat the experiment, you will find the same uh, result. And we agree that 95% of confidence is considered the significant statistical determine. So if I am 95% that this number, if repeated in another study, will be the same, or this number plus or minus a, a small margin, will be in the same. So let's make it an example, you will get it. Suppose that you are interested in estimating the average height of certain population. You take a sample of 100 individual and calculate their average height, which turned out to be 170 with a standard deviation of 5 centimeters. So the mean of the heights is 170 and the average of the heights is from 165 to 75. So most of the cohort will be in this area. Uh, so if you would like to calculate a confidence interval for the population mean height, يعني if you make this sample have a generalizability. So using the sample mean and the margin of error, you construct the confidence interval. So the confidence interval, if I know that I have margins of error, which mean that I may have in the mean some population who are 175, 169, so the confidence interval is from 169 to 171 if I know that the margin of error is only 1 centimeter. So I can tell you by 95% confidence that uh, uh, most of the patients or uh, majority of the patients will have heights between 165 and 171. So you can say with 95% confidence that the true average weight of the population falls within the range of 16 to 17. So why it's different from the standard deviation? The standard deviation tell you the majority, but here tell you the percentage of the error in mean. So mean and the percentage of error in mean. So nearly the mean of the population will be 169 to 171. But it is not the mean and the standard deviation. This is the mean and those are the standard deviation. This is the standard deviation. But here, this is the confidence interval. And this is, so if I have the experiment again on those patients, so I am 95% confident that the majority of the patient will lie between those two parts. Okay, the last part in this second part is the challenges of defining the risk. So we agree all that defining the risk is the important outcome or the important conclusion of any epidemiological study. Do we have a problems in defining the risk? Yes, we have those problems. We have the bias, the confounding factors, and the disease modifying factors. And again and again, why I am telling you these issues, because you will find all these terminologies inside the strobe checklist and inside the epidemiological studies. You will find an item telling you, is there a risk of bias? Does the author tell us how he or she avoid the bias? Is there a reporting of the confounding factor or disease modifying factor? So what is the meaning of this? So bias mean that the epidemiological studies are prone to different types of bias that can affect the usefulness of their conclusion. Those are some types of the bias, like the selection bias, when the selection of participants into a study is not random or representative of the target population. Sure, the conclusions will be also unrepresentative. Like if I am just choosing the ill population and put them in the exposure group and the healthy population in the non-exposure group, so this will affect this is a selection bias. We have information bias, as I told you, in the difference between cohort and case control. When I'm searching for the past, I can have some lost variables, some measurement imprecision, or systematic error in data collection. So it's an information bias. I may have recall bias when participants in a study inaccurately remember or report past exposure or events. So it's a recall bias. So we may have many type of bias, and any author of epidemiological study should have an effort to convince me that he or she acted well on the bias to reduce them. So what are the confounding factors and the disease modifiers? The confounding factors are the variables that can distort the true association between an exposure and the outcome. So they are variables that are associated with both the exposure and the outcome, leading to false association or masking the true relationship. So the confounding factor can create a spurious association between exposure and outcome. And as a famous example, in a study examining the relationship between coffee consumption and heart disease, if the age is not controlled, it might act as a confounder because the higher age or the age can be associated with both the coffee consumption and the heart disease. So here, it is not the coffee who caused the heart disease, it may be the advancing age. If you don't report this confounding factor, and if you don't make a statistical method to adjust for this confounding, so your results in the study or your conclusions are not 100% agreeable. What are the disease modifying factors? The disease modifying factors are variables that alter the progression or a manifestation of the disease, influencing how an exposure lead to the development or progression of the condition. The example of this in the context of lung cancer, the genetic predisposition might modify the effect of smoking in development of lung cancer. It is not a confounder, it is a modifier. Okay, if I am a smoker, okay, I have some risk to develop lung cancer. But if I am genetically predisposed to the lung cancer, I may develop more severe form of lung cancer or more aggressive form of lung cancer. It's a disease modifying factor, not a confounder. So if I make it clear what is the confounder and what is the disease modifier, the confounder distort the true association between exposure and outcome. But the disease modifier just modifies the impact of exposure. The confounder obstruct identifying the true cause between exposure and outcome. But here in the disease modifier, it influences how an exposure might act upon the disease, but don't interfere with identifying the association. This is very important. What is the adjusted analysis? Adjusted analysis in the epidemiological studies involve controlling for and assessing the influence of confounding variable to better understand the relationship between an exposure and a outcome. You will find in the studies that I'm studying the uh, uh, relative risk of smoking to developing lung cancer. Okay, but you will see an analysis which is named unadjusted or univariate analysis. Means that I'm just examining the or testing statistically the relationship between smoking and lung cancer. But you will find in the more powerful study which is called the adjusted analysis. Adjusted analysis will make a statistical model that put the smoking beside the age, beside the comorbidities, beside the environmental factor, and try to have a relative risk of each of them compared to each other to the outcome. So it may, uh, in the univariate analysis, I can find a relationship between smoking and the lung cancer, but when I am putting this factor beside the other factors, it may lose its significance or its power of inducing the outcome. And this is meaning of adjusted analysis. And this is why the papers with adjusted analysis are more reliable in results than the papers with an non-adjusted analysis. And also you will find this terminology uh, uh, in the strobe checklist. So what is the process of adjusted analysis? You should identify the confounders, make a statistical control by multivariate analyses, and assess the effect modification. This is the last part of the second part of the lecture. An example, in a study examining the association between the physical activity and the heart disease, age is identified as a confounding variable, but it is associated with both physical activity and development of heart disease. So researchers conduct an adjusted analysis by including the age in the statistical model. Initially, the study might suggest a strong association between physical inactivity and heart disease. However, after adjusting for age, the association weakens, indicating that age was confounding the relationship. The adjusted analysis accounts for the influence of age and provide more accurate understanding, and it's a critical step in epidemiological research. Here is the end of the second part. In the third part, we will discuss in brief the strobe checklist, which consists of 22 items.